Our world today, so fraught with the consequences of modern civilization's reductionist assumptions, deeply needs what Rupert Sheldrake has brought to the table of scientific discussion. The precision of his thought and articulation, the breadth of his expertise and erudition, the calm equilibrium with which he engages what has surprisingly often been fierce hostility, all these represent a model of intellectual excellence and courage for all of us. Rupert Sheldrake is perhaps as well suited as anyone living today, by training, by sensibility, and by courage in battle, to engage this task. He's a Lancelot in our round table as we seek to recover the sacred mystery of our cosmos. Let's welcome him warmly to San Francisco.
Physics is in crisis at the moment, partly because the entire cosmological explanation depends on these completely unobserved principles, partly because the most important theoretical structure in physics, superstring theory or M theory, on which 80% of theoretical physics is based, yields no testable results and has equations that would apply to the 10 to the 500 power of 500 universes. And it's so general that it makes no testable predictions at all. So a lot of physicists are now saying, is this science? And then there's the multiverse universe problem, where many physicists are now postulating trillions of unobserved universes without a shred of evidence. So some of the more radical physicists are questioning the entire enterprise. The best general introduction to this situation is Lee Smolin's book, The Trouble with Physics. He's a cosmologist who's more sensitive than most to the problems with physics. And there are quite a number of the more thoughtful members of the physics community who think it's completely lost its way. There's this group called the Electric Universe, who they have conferences, they have a website, the Electric Universe, and they have a radically different view of the way the cosmos works. I've been to a couple of their conferences, and I found them absolutely fascinating, because many people within them are electrical engineers, physicists, cosmologists. But the Electric Universe people argue that instead of the galaxies being organized primarily by gravitation, which has been the basis of cosmology since Sir Isaac Newton, instead, the main organizing forces are these vast electric currents, which everyone agrees really exist. There are incredibly active, energetic centers of generating energy in the hearts of galaxies, the galactic center, as I mentioned a few minutes ago. And there are enormous electric currents going through the plasma in the interstellar gas, through the arms of galaxies, vast electric currents stretching over millions of light years associated with magnetic field lines, millions of light years long, vast magnetic fields. And they think that the galaxies are controlled and organized through these magnetic and electrical forces which have their source in the galactic center. Now, that seems to be entirely reasonable, and it fits the facts much better than the conventional view that it's all gravity and anything that can't be explained by gravity must be explained by dark matter, which can be added in arbitrarily to explain any anomaly. If a galaxy has an unexpected bulge, then you say, well, there must be a lot of dark matter there that's pulling it out. You can explain everything with dark matter, but it's totally untestable. The Electric Universe people also they like the work of a dissident cosmologist called Halton Arp, A-R-P, who is an American cosmologist who is best known for his catalogue of anomalous galaxies. Quite a number of galaxies are called after him, ARP 507 and that sort of thing. So he's the leading American cosmologist until he came up with a heretical theory that led to him being extruded from the mainstream community and marginalized. And what he said was that if you look at the facts of the matter, the usual assumption is that the expansion of the universe leads to the redshift in objects as things move away from the Earth through the Doppler effect. Their light, the spectrum of their light is shifted towards the red. It's called the redshift. And things that are very distant from us have high redshifts of 6 or 7. Things that are very close have redshifts of 0.1, 0.2, etc. A redshift of about 6 or 7 is enormous, and it implies that something's extremely distant. Well, the most energetic objects in the universe are called quasars, quasi-stellar objects. And quasars give out huge amounts of energy. They also have enormous redshifts. Most of them have redshifts of 5 or 6. And this implies that quasars are not only very energetic, but even hyper-energetic, almost inconceivably energetic, because if we can detect them so far away, and they have these huge redshifts, they're completely unlike anything that's near to us. And the usual assumption is that these must be extraordinary, anomalous objects that are far, far away, receding from us very fast. But Halton Arp came up with a different theory. He thought that the redshifts of quasars had nothing to do with them moving away from us. He thought that quasars were newly minted matter spat out of these energetic cores of galaxies, often spat out on both sides of the galaxy. You often see quasars, one on either side of a galactic center. And that the reason they have a redshift is because it's what he calls the intrinsic redshift, that he thought newly minted matter has a redshift because its existence hasn't yet been detected by the rest of the universe. It can only be detected at the speed of light, and as the rest of the universe registers it, it reduces its redshift. Now that, I can't comment on the technical details of that theory, but this is Halton Arp's theory. And the electric universe people are very keen on Halton Arp's theory. Halton Arp himself wrote a book about this called Seeing Red, which is it's spoilt by the fact he was extremely embittered by the treatment. As soon as he came up with this theory, he couldn't get time on telescopes, he couldn't get grants, he couldn't get his papers published in journals. This extreme intolerance that's characteristic of science, because of the lack of a pluralistic model. The idea is science has a universal truth about all the universe. Therefore, you can't have two lots of cosmology. You can only have one at any given time. And scientific revolutions are usually, as in Thomas Kuhn's book, The Structure of Scientific Revolutions, are usually conceived of as being rather like those old-style Latin American revolutions where one military junta is replaced by another. It's still a dictatorship. That's an aside. But anyway, the Halton Arp's views are part of the electric universe theory, and their most radical theory, the one I found completely intriguing when I heard a talk on it at one of their conferences, is that the sun is not powered from within, as conventionally believed by the hydrogen bomb theory, but powered from without. That there are huge electric currents passing through the universe. They enter the the whole sphere of the solar system. They pass through, they're attracted towards the sun. And the light of the sun, most of it's generated by something a bit like lightning moving into the sun from outside. And the proponents of this theory have quite good arguments. The photosphere, the surface of the sun that we see, has a temperature of about 5,000 degrees centigrade. The corona that you see during eclipses, the gaseous bits around it, which you can't see normally, have temperatures of about 5 million degrees centigrade. So how come, as you get further from the center, where the energy is supposed to be produced, the temperature, instead of going down, goes up so dramatically? Well, the theory that the sun's powered from outside makes more sense of that than the existing theory, which keeps changing. They say, oh, well, it's caused by the reconnection of magnetic field lines. That's the usual theory. You say, well, how exactly does that work? And when you ask the questions, then you say, oh, well, so-and-so thinks it happens this way, but we think it happens this way. And then another critic says, no, they've got it all wrong. So it's not as if there's an agreed theory of reconnection of magnetic field lines. It's an attempt to explain a phenomenon that simply doesn't fit into the existing model. So the electric universe theory, I think, has many merits, but it's been completely excluded from the official astronomy thing. And And well, I use my friend Martin Rees as a kind of sounding board. So I said to him once, "What do you think about Halton Up?" And he said, "Well," he said, he used to be eminent cosmologist, but he's completely discredited. No one takes him seriously anymore. I said, "No one." He said, "Well, within the mainstream physics community, no one." And that was it. I said, "Well, can you tell me why?" He said, "Oh, I can't waste time on the details." So, this is, this heresy-creating mechanism that's so well established in science. So it's very interesting that currently they've got some funding and they're building a model of the sun in a huge plasma chamber, and they're trying to make models of plasma discharges to model how this energy system could work. Let me just say in parenthesis that I was at a fascinating meeting about 3 years ago in Albuquerque, New Mexico, that was convened by the Electric Universe people. And after it, they had a one-day invited symposium of about 6 or 7 people. I was one of them. An eminent professor of physics from Washington State University was another. Dean Radin was one. And there were somebody from the Department of Defense, someone from the Lockheed Corporation, someone from a think tank in Washington. And the basic thing was a discussion about the innovation deficit in science. What can be done because the structure of science is set up in such a way that it inhibits innovations, as I've mentioned already, for ideological reasons. But also, they've identified this as being, in this discussion, the think tanks have identified the main reason as being what they call perverse incentives. Within the scientific world, the way you build a career, the way you get your grants, the way you get promoted, the way you get top jobs, is through the number of citations to your papers in peer-reviewed journals. The number of papers times the citation index gives a quantitative measure which gives your status in the scientific world and is what your career is all about. It has nothing to do with making the world a better place, breakthroughs that could change technology or anything like that. It's to do with citations within the peer-reviewed literature, quantified. Now, if you work in an innovative field of science, which by definition won't have many people working in it, you won't get many citations because there aren't many people in the field. You'll get the most citations if you work in highly populated areas of science like string theory or molecular genetics. So this favors people working in conventional areas, and it's perverse incentive for non-innovation. Anyway, there's a chap called Gerald Pollack, who's a professor at the University of Washington, works on water, has very innovative work on properties of water, who launched the idea for something called the Institute for Venture Science, for which he's been trying to collect billions of dollars from aging Silicon Valley billionaires on the principle they can't take it with them, and the best thing they could do if they believe in innovation is to give the money to a fund that could actually encourage innovation. And his argument is that in every branch of science there are these extruded, marginalized groups like the Electric Universe, parapsychology. Within the water research, there's a whole group of water researchers who have been, including memory of water people, who have been squeezed out of the academic mainstream. He said these are the low-hanging fruits. He said if I had a fund with several $1 billion, he said what we should do is fund all these marginalized groups, not just one lab, but several labs within each group, because these are the places where there's most likely to be breakthroughs. They're areas where serious people have spent years and endangered their own careers doing innovative research, where these are the areas innovation will come from, and by doing that, science would be transformed. I think he's completely right. And the Electric Universe is precisely one such group. So this is a long answer to your question, but I think that the Electric Universe group is, I mean, it's interesting, even here, very few people know about it because it could have a bearing on, cosmology and some of the things that you discuss. But it's simply not on the radar for most people because the scientific media, science journalists don't report anything done in these conferences. They're treated as fringe or, crank or something not taken seriously. You wouldn't read about it in the New York Times or Scientific American or anything like that. And most politicians and funding agencies and professors and intellectuals get their information from these kinds of organs, serious journalist organs. And serious scientific journalists would never report on these things.